This is the database interaction activity in C#. I have the solution open in Visual Studio. Looking through, the first step here is to research different mechanisms and APIs for interacting with databases in C#, and I recommend you do that research on your own. I'm going to implement two different mechanisms. The first is going to be Entity Framework, and the second is going to be ADO.NET. There are several other libraries and mechanisms for dealing with databases in C# and in the .NET world. So looking at our local environment, what we're going to do is we've got the solution open already. We'll verify the tests are failing in the Test Explorer window, and then we'll publish the database project. This is using SQL Server. We're going to use a project here, a database project. You can see it on the right here, to publish this database locally. Once that's done, we'll implement the two different ways of doing database access. And again, I'm going to do two completely different ways. There's kind of two models for database access. The first is an ORM, which is an object relational mapping engine, and the other is a command query interface. So I'm going to implement one of each, and I'm going to do that for all the languages. So we'll start off with Entity Framework, that's an ORM, and then we'll go to ADO.NET, that is a command query interface. We'll use our test to drive through the design and make sure everything's working, and then we'll make sure that everything is passing by the end of it. So let's jump in. Let me start off by running the tests. This may take just a minute since it needs to initially compile, build, run the tests. We should get 2 failures, and we do. Make sure we get the right failures, which is excellent. So we have not implemented exceptions, which is what I'd expect. So let's dive into the test, start off here. So commercial property, what we're doing is we're creating a commercial property, so an instance of that class. We're giving it an address, and then we're saying, hey, save this property to the database, call save. Then we get all of the properties from the database, and then we make sure that there is a single saved property, so one and only one. And then finally, we'll make sure that the commercial property and the saved property records are the same, that those two objects are the same record. So that's the idea of what we're doing here. We're doing the same thing on the residential, just making sure that we create a residential property, save it, retrieve all of them from the database, make sure there's one, and make sure it is the record that we saved. So these don't work. We'll start off in, and I'll use basically one of these two classes to do Entity Framework, and the other to use ADO.NET. I'll choose the commercial property class to be the Entity Framework instance. Now the next thing we need to do is publish our database. So I'm going to go down to the database.local.publish.xml file. I'm going to right click and say publish. This is going to open up a dialog for me. Make sure all my settings are correct, and I'll just hit publish. This will create the database locally. I'll move my big head here. We'll see it take a few seconds to connect to the database locally, publish it, I get a green check, everything is published. So now this database exists in SQL Server on my local instance. You can connect using SQL Server Management Studio to verify that that's there, but that created that database. So now inside the commercial property, we need to implement Entity Framework. This is a good time if you've never used Entity Framework or you're rusty on it, you don't remember, do an internet search. Entity Framework, get started. There's going to be several articles that pop up. Usually the Microsoft articles are pretty good. You may get some help with AI, so lots of different ways that you might be able to go about that. Effectively, what we're going to need to do is create 2 classes here. One for the DB context, which represents the connection to the database, and the other is the record that represents the table, the commercial property table. So I'm going to put all this in a new folder inside my properties, which is short for real estate properties, my properties library. So I'll say add new folder. Let's just call it data. And in data, I'm going to add a class. And I want it to be the same as the name of the database project, or the database itself, which is White Belt Real Estate. So I'm going to say right click, add new class. This will be my White Belt Real Estate DB context. By convention in Entity Framework, we end the class name with DB context. So that creates my DB context class. I'm going to derive from DB context, which is not there. So I now need to install through NuGet. I need to install Entity Framework. So let's go right click on the project. So this is the properties project again. We'll say manage NuGet packages. Here it is. And now we're going to go to browse. We'll say Entity Framework. And we're looking for the SQL Server, since that's the database to which we're connecting, Microsoft.entityframeworkcore.SQL Server. Let's install that. I can hit the down arrow to install it locally. It's going to ask, are you sure you want to install all these packages? It's a lot of packages. Keep in mind, Entity Framework is heavy. There's a lot of things coming along for the ride. All of these different third-party packages are going to be installed. That's a lot. So there is some overhead that comes along with this. I will accept it. All right, now that that's installed, let's head back. Now my DB context, it now knows where that namespace is. So I'll go and add that namespace. and it resolves. From here, I need to do a few things. I need to know how I'm going to create an instance of this DB context, this connection to the database. There are several different ways to do this. Most of the ways you're going to see on the internet are based on dependency injection. I am not going to use DI. Instead, what I'm going to do is I'm going to create a static factory method. So, and this is just a simpler way of doing things. I'm not saying DI is bad. In general, I try to avoid DI. This isn't necessarily a good practice either, but it's quick, it's easy, it's fast, and you can see how things connect together. So that's why I'm going to do it this way. So we'll create our constructor, and by default, we need to pass in DB context options, and those are going to be passed to the base constructor. So this is a private constructor. We cannot see it outside this class. So now we're going to create our factory method. So this will be static DB context. We'll create an instance. And now here, what we're going to do here is we need to create the options and then return the DB context. So we'll say options builder equals new DB context options builder of type DB context, or our DB context. Then we'll say use SQL Server. And with using SQL Server, it's going to ask for the connection string. So we'll go ahead and put that in here. It's going to be data source equals period / Lucent Terry, because that's the name of our local database instance. The initial catalog is going to be white belt real estate, because I copied and pasted it specifically, so I had that value. We're going to use integrated security, which is our Windows credentials, so SSPI. And then finally, we need to trust the server certificate. Yes. So there's our connection string for our SQL Server database. Finally, we'll return a new instance of this class given the options from the options builder. So this creates our instance. Now we're going to be able to use it. The other thing I need to do as a part of this class is I need to create, and everything I'm doing is just part of Entity Framework. I need to create a property that represents the table for the commercial property records. So we'll create our properties section. We'll say public. This is going to be a DB set, and a DB set of the type of object I'm holding on to. Now we could use commercial property here, but the problem is we already have a commercial property class. I can namespace them, I can keep those separate, but just to make sure that we keep them completely independent, I'm going to say commercial property record. So this commercial property record class will represent the database object, whereas the commercial property class that we already have will represent the business concept or the domain concept of the commercial property. So there's our commercial property record. We'll say this is commercial properties because this is the collection of all of them. And now I need to create this class. This class is also going to be in the data folder. Commercial property record. And this class, so this is going to resolve this error here. There it goes. This class needs to map to the database record. So looking at the database record, let's go to the commercial property.sql. We can see there's an ID property that's a unique identifier. This is the primary key. You can see that here. We have a street address, city, state abbreviation, and postal code. All of these are going to be strings: varchar, varchar, char, and varchar, so character fields. So I need to create all of these here as properties. I can look at the commercial property class to give me a head start. The 4 properties are here for the strings. All I need to do is create the actual, the primary key. So we'll say key. It's going to add in our data annotations public. Now this is not an int. This is going to be a GUID for a unique identifier. Then the other properties are simply going to be strings, so I will paste that in. And I'll use a little block select magic. To create my properties. And then we'll alphabetize, because I'm a big alphabetizer, so we'll make sure everything is alphabetized so it's easy to find properties later. And that basically is the mapping of the database columns. Now I also need to make sure that the name of the table is specified, because it's not the same as the name of the entity set. So this is the name is going to be commercial property, not commercial property record and not commercial properties, plural. So I want to specify the name of the table to make sure it knows how to map and find the actual database table. Here's our columns for our mappings, everything's set up. So now I've got my entity record, I've got my DB context record, everything looks good there. Now we're ready to start implementing our functionality in the commercial property class itself. So we'll start off with get all. What we're going to do here is we're going to create one of the DB contexts. We'll say using var DB context. Using is here because this is going to automatically close the DB context when we're done and dispose of any objects. So this is a disposable object, so we're going to use using. DB context equals, so this is going to be the white belt real estate DB context dot create as the static method we created. Now that I have that, I want to get all the records. So we'll say all commercial properties equals DB context dot commercial properties. Here's the DB set property we created. And to get all I need to do is just say toList, toArray, something that enumerates the collection. This toArray method here will actually open up a connection to the database, retrieve all the records, map them back to our objects, and pull them back into memory. Now that I have those are commercial property records, but I need to turn them into commercial property objects. So I'll do a simple projection in C#. We'll say return all commercial properties dot select. So this is going to be a projection. We're going to say for each one, select something else. So we'll say commercial property record, given one of these, we're going to create a new commercial property. The commercial property needs a street address, city, state abbreviation, and postal code. So we'll pass in commercial property street address, city, state abbreviation, and postal code. I'm doing these on new lines just so it's a little easier to read. And then finally, we need to make this concrete, so I will just take it to array. Could also do to list. When I need something to be read-only, I prefer arrays because arrays are harder to mutate in the C# environment. Not impossible, but just harder to add and remove from those. So there's my get all. I can now pull all those records back. Now I also need to do a save, so let's do that now. So again, we'll say using var db context, because this is going to be, again, the DB context is the connection to the database, so I need to pull that in. Now here what I'm going to do is I'm going to add to the commercial properties a commercial property record from this instance. So say db context.commercial properties add some new commercial property record, and now it is going to want the properties, and IntelliSense is trying to help us out here, equals this dot street address, city is this city, state abbreviation, this state abbreviation, postal code is this postal code. We've added that record, and then finally we need to tell the DB context, save all these changes. That is going to do all insert, update, deletes that I have batched up and send those all off at once, which right now is just a single insert into the database. That looks right. Let's go ahead and run the commercial property test and see if everything's working. We have a pass. So it's inserted the record into the database, it's retrieved them all from the database and made sure they all match coming back out. So everything's looking good there. Let's go ahead and move on to the residential property now. So the residential property, what we're going to do, instead of Entity Framework, we're going to use ADO.NET, completely different library. Again, good internet search to get started is ADO.NET, get started. There's lots of different articles and lots of different ways to do this. I'm going to do this fairly simple. Again, I want you to be able to see how all of this applies together. So in order to use ADO.NET, in order to use SQL Server's ADO.NET, we are going to need to import another library. So I'll go ahead and right-click and say Manage NuGet Packages again on the Properties project. And we will say what we're looking for is the SQL client. The SQL client is the client to the SQL Server database. So here's my Microsoft.data.sql client. We'll go ahead and install this package. And again, it has several packages, not as many as Entity Framework, but several packages that are going to come along for the right. We'll accept that. That'll install those. Give me just a moment. Close this out. Now we can use our ADO.NET code. So to do this, what we're going to do is, again, there's going to be a using to automatically close. We'll start off with a connection to the database, and I'm going to simply create a method that's going to create my connection. I'm going to do this because I'm going to need a connection in both of these methods, and I don't want to repeat too much code. So we'll say private static IDB connection, create connection. This is going to be a method that simply returns a new SQL connection. And the SQL connection wants the connection string. I'm going to copy this from my DB context here that we've already done, just to make it simple. I've already put it somewhere, so I'll copy that in. Normally, you would pull this from a configuration value. I want this to be simple. I want you to see how everything works together, so I'm simply going to put the connection string in. This is how we're going to connect to the database. Now that we have our connection, the next thing we need to do is we need to create a command. The connection has a method for creating a command. This is an abstract factory pattern. So now that I have the command, what I want to do is give it the text. So we'll say the text is select star, so select everything from dbo.residential property. So there's my command. I want to get everything from that database. Now I need to populate some sort of collection or list of residential properties. So let's create that. So we'll say var residential or all properties equals new list of residential property. Here, what we need to do is open a connection. The connection's not open yet. We'll open the connection. We will read the records, populate the properties, and then return them back. So connection.open, that will actually connect to the database. We'll say using var reader equals command.execute reader. A reader is from a select, and it lets us iterate over the records. We do that with a while loop generally. So we'll say while reader.read, so while there's another record available in the return set, we will simply add to our properties. And again, it wants the street address, city, state abbreviation, and postal code. There are several ways to get these values out of the reader. I can say get string, and it wants the ordinal or the index of the column, so 0, 1, 2, 3, 4. So if I know the order, I can do it that way. I can also read given basically the column name using the indexer notation, which is the square brackets. I can also read using indexer notation with the name of the column. That's what I'm going to do here because I don't necessarily want to rely on the order of the columns. I could do that by specifying the order here instead of star, but since I'm doing star, I'm going to specify the name so I get exactly what I want back out of it. So I want the street address record. Now this is a string, so I need to cast it out as a string. There's my street address. I'll do the same thing on the other, so city. And these values, street address, city, and the strings here, these need to match the column names, not the property names in C#. These are going to be the database column names as they appear in the database. It just so happens that I mapped those together just to make it easy, but what's in the strings here, reader, again, state abbreviation, this needs to map the column names, not the names of the properties here. And then finally, postal code. Close all my parentheses. And then finally, now that I've added the records once we go through, we'll simply return all properties. I'll take this to an array. Again, a little less easy to mutate that collection. I didn't close the connection because it's in a using, the connection will close automatically. I could force it, I could say connection.close, but again, the using statement is going to do that for me. Finally, we want to implement the save. We're going to do some of the same code, so we'll copy these first 2 lines here. There we go. So we create our connection, we create our command. Now our command text is going to be quite a bit different. Instead, this is going to be an insert. I'm going to do this is going to be long, so I'm going to do this on multiple lines. So I'm going to use the @ sign. Insert into dbo.residential property. So there's the name of the database table into which I'm inserting. Open parentheses, and now we're going to list out the column names into which we're going to insert. So looking at this table, ID is a primary key and it has a default of new ID. So it's going to add the value for ID automatically. So I just need to implement or add the other columns. So we'll say street address, city, state abbreviation, and postal code. And now the values are going to be parameters. Parameters in SQL Server start with the @ sign, and we'll just call these the same thing, just lowercase with the @ sign. All right, there is our command text. So pretty lengthy command there, pretty lengthy SQL statement. So insert into the residential property table the columns, and then the values are going to be parameters to which we're going to bind. So next thing we need to do is we need to add those parameters. So I'll say parameter equals command.create parameter. This is going to create an object to which we can bind the values for the parameter and add it back. So we'll say parameter.dbType equals, these are each strings. The parameter name is going to be street address. And notice the parameter name, lowercase, lowercase. SQL Server doesn't necessarily care about the case, so I probably could have gotten away with a capital S. However, I want you to see that this parameter name is matching the @ symbol parameter name. You could put the @ symbol in front of it. It will add the @ symbol automatically for you, so you don't necessarily need to specify the @ symbol here, but you could. You could add the @ symbol and it works just fine. And then finally, the value is going to be this .street address. Once that parameter is created, I need to add it to my command. So we'll say parameters.add parameter. So now we are going to copy and paste this because we are going to do this 3 more times. 1, 2, 3. So the next one is not street address, it is city. Everything else is the same, it is still a string. The next one is state abbreviation. And then finally, postal code. Now that I have all of my parameters added, I'm finally ready to connect to the database and execute the command. So we'll start off with our connection. We'll open the connection to the database, command.execute. This is going to be a non-query. So it's just a command. We're not querying or interrogating for anything. We're simply executing. Execute non-query will give me back an integer that is the number of rows affected. You're welcome to interrogate that. You could basically hold on to that and say var rows affected equals, and then do something with that. If rows affected is not equal to 1, for example, we could do something with that. You could throw an exception, you could log something off, all sorts of different things you can do. I'm simply going to let it, if it errors out, bubble up, the test will take care of it for me, so I'm going to ignore the return value for us. That should make everything work. Let's go ahead and run our test for the residential. And it passes. So those are working. Now let's go and run all the tests again. And they fail. What's going on? So each of these tests is saying, hey, I expected a single element, but I got multiple elements, and these are in the assert single. So what's happening is each time that we run the tests, we're not clearing out the data in the database. We're adding to it as we go. So we do need to clear that out. This will happen sometimes in tests. So let's go ahead and take care of that. At the beginning of each test method, I'm going to create a method that simply says reset database. I'll add this on both of these. And now let's create a method to do this. Private static void reset database. Too many parentheses. So we are going to reset the database. Again, all sorts of different ways to do this. I'm just going to use ADO.NET. So we'll simply pull from what we did before. So we'll say using var connection equals new SQL connection. It wants the connection string. So let me pull this again from residential property. And we'll just copy all of this. So there's our connection that opens the database connection. We'll say using var command equals connection create command, our command text in this case. There's several different ways to do this. I can delete, I can truncate. I'm going to use truncate. It works in this case because I don't have foreign keys that I have to worry about. So we'll say truncate DBO, truncate table, DBO, residential property. I don't think I need table. I think it's just truncate. We'll try it and see if it works. If it doesn't, we'll add the table back. Truncate DBO, commercial property. And then connection open, and finally command execute non-query. Let's run our tests again. They'll either fail really fast or they will succeed really fast. All right, they failed. So yeah, I do need truncate table. And again, if you're not sure about the syntax, quick internet search will help you out. Run the tests again. There we go, we have passes. I'll run them one more time just to make sure. We have passes. Notice the time difference between these two tests. The ADO.NET version was 3 milliseconds. It's incredibly fast. Whereas the Entity Framework version took almost half a second, 487 milliseconds. 500 milliseconds would be half a second. The Entity Framework has a lot more overhead going on. Sometimes that's worth it, sometimes it's not. So again, just two different ways of doing things. We saw the Entity Framework version. So I created my DB context, I created the record for it, and then inside the code, we pull from the DB context, we can select from the commercial properties, and then we can add to them for insert. The other way is ADO.NET, that's in the residential property, where we simply open up a connection, create their command with the command text. So the command query, here's our query text. We open up a reader since we're querying, and while reading, we add to it. And then our insert, we create a command. We call the insert command, the insert text, add our parameters, and then finally execute non-query. Two completely different ways. There's lots of other libraries out there. Another really popular library that sits just on top of ADO.NET is Dapper. It's a really, really nice, lightweight ORM. Kind of bridges the gap between ADO.NET and Entity Framework. But there's a lot of different libraries out there in Hibernate, et cetera, et cetera. So that basically concludes the database interaction activity in C#.